Now students, this is a shortcut method for identifying the starting direction. Whether you are drawing the polar plot whose starting direction will be correct or not, you can cross check with the finite pole or finite zero concept. Remember, finite pole, finite zero means it must and should lie on left hand side of S plane. So similarly, is there any chance of ending direction? Yes, there is a shortcut procedure for the ending direction of the polar plot also. Ending direction of the polar plot. This is the ending direction of the polar plot. So how we can verify the ending direction of the polar plot? So the ending direction of the polar plot, you can cross check whether your diagram is correct or not with this particular procedure. Now first we should measure the phase. Now phase difference, what is the phase difference? The phase difference is nothing but starting phase minus ending phase. Starting phase minus ending phase. Omega equal to 0 is the starting phase. Omega equal to infinity is the ending phase. Measure the phase difference. The phase difference is nothing but the starting phase minus ending phase. Starting phase minus ending phase. Starting phase means omega equal to 0. Ending phase means omega equal to infinity. This is the phase difference. Now if this phase difference is positive, if phase difference is positive, the ending direction of the polar plot is ending direction of the polar plot. The ending direction of the polar plot is clockwise direction. If the phase difference is negative, the ending direction of the polar plot is anti-clockwise direction. Okay, so this is the phase difference. The phase difference is positive. When the phase difference is negative, starting direction is clockwise, ending direction is anti-clockwise. Phase difference means starting phase minus ending phase. You will cross check this with. See the students. Now 0 degrees is the starting phase. Ending phase is minus 90. Difference, what is the difference? 0 minus of minus 90 plus. So phase difference is positive. If phase difference is positive, what he is saying? Ending direction is, which direction? First you check here. Ending direction is clockwise direction. But what he is saying? Phase difference is positive, ending direction is clockwise. Is matching or not? Yes. Now come to here. Phase difference 0 minus of minus 180. Therefore, phase difference is positive. Now what is the ending direction? See the ending direction, omega equal to infinity. This is the ending direction. Now the ending direction is which direction? Clockwise direction. Is matching or not? Come to here, phase difference. Now what is the phase difference? Again positive. Minus 90 minus of minus 180, positive. So if the phase difference is positive, ending direction of the polar plot is, see here which direction? Ending direction is clockwise direction. Ending direction means omega equal to infinity. Ending direction is clockwise direction. Matching? Here also, ending direction is clockwise direction. Matching? Here is also, ending direction is clockwise direction. Is matching or not? So if the phase difference is positive, ending direction is clockwise direction. Phase difference is negative, ending direction is anti-clockwise direction. Okay, note down these are the also shortcut method. Now based on the phase differences, okay, based on phase difference, starting phase minus ending phase. Okay. Now with this you can easily identify that then your polar plot is correct or not. You can easily cross check. Now students, g of s equal to 1 minus 1 by s minus 1. So now the students are immediately blindly going that type is 0, order is 1. So most of the students are saying that, sir, you said that the type and order method, can I apply the type and order method because only denominator polynomial. Okay, if you go like that, this is 100% the wrong results. Why? Because now what I am saying is type and order approach, all the shortcut methods I am saying except this ending direction. Okay, ending direction will be available everywhere because this is based on phase difference. Okay, all the shortcut methods are valid only finite pole, finite zeros. Type and order means finite pole, finite zero. What is the meaning of finite pole and finite zeros? A finite pole and finite zero means it must and should lies on left hand side of its plane. But where is here? S minus 1 equal to 0, s equal to plus 1. This is not a finite pole. Not a finite pole. Don't use the type and order approach. Therefore, type and order method is not at all useful, and finite pole and finite zero concept not at all use. No, don't use this method. Don't apply this type and order method. Don't apply finite pole and finite zero, which will give the wrong results because this is not at all a finite pole. Type and order method, finite pole and finite zero concept, all shortcut methods are valid only when the poles and zeros lies on left hand side of a plane. But this is the right hand side of a plane. Don't use the shortcut method. Go for the long method. Replace s equal to j omega. G of j omega, which is equal to 1 divided by minus 1 plus j omega. Magnitude is 1 divided by square root of a square plus b square. Phase angle is denominator minus, and you observed or not? This is the real part. If the real part is negative, when the real part is negative, n number of times I am saying, when the real part is negative, angle is not 0 degrees, angle is 180 degrees. Therefore, this is nothing but 180 degrees plus tan inverse imaginary part by real part. Real part is minus 1. Therefore, this is nothing but tan inverse of minus omega. Therefore, this is minus tan inverse. Therefore, which is nothing but 180 degrees minus tan inverse omega. But this total is in the denominator. Therefore, minus. Again, the phase angle is depends upon frequency. The phase angle is depends upon frequency. Therefore, polar plot is not a straight line. It is a long path. Therefore, when omega equal to 0, when omega equal to 0, something by 0, omega equal to 0, this is 0, but this is 1, 1 at angle of minus 180 degrees, and so on and so on and so on. When omega equal to infinity, something by infinity, infinity plus 1, infinity, something by infinity is 0, at angle of tan inverse infinity is 90, 180 minus 90, 90 into minus 1, minus 90 degrees. Therefore, now your polar plot is depends upon frequency, no shortest path, a long path. Therefore, now see here, first you should indicate minus 180 degrees. Now this is minus 180 degrees line. This is minus 180 degrees. Next ending line, ending angle is minus 90 degrees. Then now you see here, in minus 180 degrees magnitude is how much? In minus 180 degrees magnitude is 1 somewhere. 1 at angle of minus 180 degrees when omega equal to 0. Now your journey is starts at minus 180 degrees and go to minus 90 degrees. In minus 180 degrees, your journey is go to minus 90 degrees. In minus 90 degrees, magnitude is, in minus 90 degrees, in minus 90 degrees, magnitude is 0. 0 at angle of minus 90 degrees when omega equal to infinity. Now this is the direction of the polar plot. This is the direction of the polar plot as frequency is changing from 0 to infinity. Okay. Then you cross check. So if you go for type and order method, that answer is different and this answer is different. Okay. Because this is not applied a type and order, because this is not a finite pole. Now see here, sir, how I can check this is correct or not? So I am not applying a finite pole and finite zero concept. I am not eligible for type and order concept, but you are always eligible the ending direction concept. Ending direction is based on starting phase minus ending phase. What is the starting phase minus ending phase? See here, this is the starting phase minus ending phase. This difference is what? Minus 180 degrees minus of minus 90 degrees. This difference is negative. When the phase difference is negative, see here, when the phase difference is negative, the ending direction of the polar plot is anti-clockwise direction. But what you are getting, where is the ending direction? This is the starting direction. See the ending direction here. Omega equal to which direction this is? This is clockwise, but this is which direction? Anti-clockwise direction. See here, this is ending direction, which is anti-clockwise direction. Is correct or not? Anti-clockwise direction. And what the shortcut method is saying, and this will be saying, is exactly matching or not. Therefore, what I am saying is, if it is only finite poles, finite zeros, now then only the type and order approach is valid. Then only the starting direction is clockwise or anti-clockwise, you can be guess. If it is not a finite pole, if it is not a finite zero, don't apply type and order approach. Don't apply finite pole and finite zero concept. Clear or not? But this is valid for all the problems because this is based on the phase calculations. After calculating phase, you apply the shortcut method, which is always available. Okay, note down this problem. Okay. So while you are doing this, drawing the polar plot, remember all the shortcut method which is useful to you. But which shortcut method is applied? This is the way we can apply or not. For this problem, we can apply the shortcut method or not. You can cross check. Okay. Okay. Students, then you just remember only one point. Finite pole, finite zeros means left hand side. Then you apply type and order, or you can apply starting direction clockwise or anti-clockwise with the shortcut method. If the poles and zeros on the right hand side, don't apply any shortcut method, but you cross check phase difference because that is calculation of the phase. So that will be verified everywhere. Okay. So G of S, which is equal to 1 by S. What is this? One pole at origin. One pole at origin. Replace S equal to J omega. G of J omega. 1 divided by 0 plus J omega. Then what is the magnitude? 1 divided by square root of A square plus B square. Phase angle is denominator minus tan inverse imaginary part by real part. Now 1 by omega, phase angle is minus tan inverse infinity is 90 degrees. Now the tan inverse infinity, which is equal to minus 90 degrees. Now the phase difference is minus 90 degrees. Now the phase you just observed here, this is completely independent of frequency. Now the phase angle is completely independent of frequency. Now the phase angle is independent of the frequency means then you can apply all the frequencies. And now see here, omega equal to 0, infinity at angle of minus 90 degrees. Omega equal to 1 at angle of minus 90 degrees. Omega equal to 2, 0.5 at angle of minus 90 degrees. And so on and so on. Omega equal to infinity, something by infinity, 0 at angle of minus 90 degrees. Now, and so on and so on. So now you see here, now omega 0, omega 1, omega 2, whatever it may be, the phase angle is minus 90 degrees, minus 90 degrees, minus 90 degrees. Therefore, you select the minus 90 degrees line first. Where is the minus 90 degrees line? This is minus 90 degrees line. In minus 90 degrees line, what is the starting magnitude? The starting magnitude is infinity. When omega equal to 0, infinity at angle of minus 90 degrees. As frequency is increasing, now your magnitude is decreasing, 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 decreasing. When omega equal to infinity, 0 at angle of minus 90 degrees, 0 at angle of minus 90 degrees. Where is the polar plot? Now see the polar plot. Now this is the polar plot. And where is the direction? This is the direction of the polar plot. Now you observe the polar plot of this particular problem and remaining all the previous problem. What is your observation? The polar plot here is a straight line. When you can get a straight line? The polar plot is a straight line only when the angle is completely independent of frequency. Okay, this is also very important point. Polar plot is a straight line only when the angles are completely independent of frequency. But what is the previous problem? Your angle is depends upon frequency. That is the reason why the polar plot is not a straight line. Understand not? And one more thing here. What is the polar plot of one pole at origin? The polar plot of one pole at origin is a straight line. Can I write like this? The polar plot of one pole at origin is a straight line. Which will cover the entire which axis? This is imaginary axis. Which imaginary axis? Negative imaginary axis, which will cover the entire negative imaginary axis, and the direction is towards the origin. This is the polar plot of 1, 0 at origin. Clear or not? Is a straight line which will cover the entire negative imaginary axis and the direction is towards the origin. Now similarly, now what I am doing is g of s, which is equal to 1 by s square. I just add one more pole at origin. Now what happened? Replace s equal to j omega. G of j omega, which is equal to 1 divided by 0 plus j omega whole square. Now 1 divided by square root of a square plus b square whole square, phase angle denominator minus tan inverse imaginary part by real part. How many? 2 times. Therefore square root cancel. 1 by omega square. Phase angle is tan inverse infinity is 90 into 2 minus 180 degrees. Now your phase angle is independent of frequency. Therefore, when omega equal to 0, something by 0, infinity at angle of minus 180 degrees. When omega equal to 1 at angle of minus 180 degrees. When omega equal to 2, 1 by 4, 0.25 at angle of minus 180 degrees, and so on and so on. When omega equal to infinity, something by infinity, 0 at angle of minus 180 degrees. Now students, this is a minus 180 degrees line. Now you select minus 180 degrees line. Now in minus 180 degrees line, what is the starting magnitude? Infinity. When omega equal to 0, infinity at angle of minus 180 degrees line. Now when omega equal to infinity, something by infinity, 0 at angle of minus 180 degrees. Where is the polar flat? See the polar flat and indicate the direction. This is the polar flat. This is the direction of the polar flat. Now what is the polar flat? This is the polar flat. Polar flat of one pole at origin. Now see here, students, which is very important point. This is the polar flat of one pole at origin. Now I add one more pole at origin. What is the polar flat? This is the polar flat. Then what happened to the total polar flat? So they add one pole at origin. The total polar flat is shifted by, this is the polar flat. Then it is shifted by, total polar flat is shifted by minus 90 degrees. But which we already discussed. Am I not? In the previous things also, the addition of each pole at origin shift the total polar flat by minus 90 degrees. Will be matching or not? Now you add one more pole at origin, then this is the polar flat. One more pole at origin, this is the polar flat. And the direction is towards the origin. And the polar flat of two pole at origin, again, is a straight line which will cover the entire negative real axis, and the direction is towards the origin. Am I not? So can I find one shortcut method directly? You can easily find. Now see here, this is the polar flat of one pole at origin. This is the polar flat of two poles at origin. This is the polar flat of three poles at origin. This is the polar flat of four poles at origin, like this. So the addition of each pole at origin shift the total polar flat by minus 90 degrees in clockwise direction. Clear or not? Okay. Now this is the polar flat is a straight line only when the angles are completely independent. Okay, no doubt. Okay. Now similarly, can we do it for this? Now g of s equal to s, 1 0 at origin. Now replace s equal to j omega, 0 plus j omega, 0 plus j omega. Magnitude is square root of a square plus b square. Phase angle is numerator plus tan inverse imaginary part by real part. Therefore, root square cancel omega, and this is plus tan inverse infinity is 90 degrees. This is plus 90 degrees, and which is completely independent of frequency. Completely independent of frequency. Now, when omega equal to 0, 0 at angle of, whenever the phase angle is independent of frequency, in your mind you should remember this point. A polar plot is a straight line only when the angles are completely independent of frequency. Is it right or not? Now, 0 at angle of plus 90 degrees. When omega equal to 1, 1 at angle of plus 90 degrees, and so on, and so on, and so on. When omega equal to infinity, infinity at angle of plus 90 degrees. Now, plus 90 degrees. Where is plus 90 degrees? This is plus 90 degrees. Now, when omega equal to 0, when omega equal to 0, 0 at angle of plus 90 degrees. When omega equal to 1, 1 at angle of plus 180 degrees, 2 at angle of plus, 3 at angle of plus. When omega equal to infinity, infinity at angle of plus 90 degrees. Now, where is the polar plot now? The polar plot is a straight line. The polar plot is a straight line which will cover the entire positive imaginary axis, but the direction is away from the origin. What is the difference between polar plot of 0 set origin and pole set origin? The polar plot of 0 set origin is away from the origin. The polar plot of pole set origin is towards the origin. So what is the polar plot of 1 0 at origin? Is a straight line which will cover the entire positive imaginary axis, and the direction is away from the origin. Away from the origin. Okay, and the direction is away from the origin. Now similarly, so can I write like this? G of s which is equal to s square, 2 0 set origin. Now replace s equal to j omega, g of j omega, 0 plus j omega whole square. Therefore, the magnitude is square root of a square plus b square again whole square. Phase angle is plus tan inverse imaginary part by real part, 2 square root cancel, omega square plus 180 degrees. Again the phase angle is independent of frequency. Definitely a polar plot is a straight line. So omega equal to 0, 0 at angle of plus 180 degrees, omega equal to 1, 1 at angle of plus 180 degrees, and so on. Omega equal to 1, 1 at angle of plus 180 degrees, omega equal to 2, 4 at angle of plus 180 degrees, and so on, and so on, and so on. When omega equal to infinity, infinity square at angle of plus 180 degrees. Now where is plus 180 degrees line? Plus 180 degrees line. This is plus 180 degrees line. In plus 180 degrees line, what is the magnitude? 0. So when omega equal to 0, 0 at angle of plus 180 degrees, 1 at angle of plus 180 degrees, 2 at angle of, 3 at angle of, 4 at angle of, 5 at angle of, and omega equal to infinity, infinity at angle of plus 180 degrees. Now where is the polar plot? This is the polar plot, and the direction is away from the origin. Now what you observed here, now this is 1 0 at origin. Dear students, this is 1 0 at origin, right? This is 1 0 at origin. Now you add one more 0 at origin. This is the total polar plot. Now this is the total polar plot is shifted by, what happened now? Now the total polar plot is shifted. This is 90, this is 180. So the addition of, then what is your conclusion? Take one note, important note. The addition of each 0 at origin shift the total polar plot by, plus 90 degrees. Shift the total polar plot by plus 90 degrees. Plus 90 degrees means which direction? Anti-clockwise direction. See here, this is 90, this is 180, this is 270, like this. So can I form one shortcut method here? So this is the plane. Now where is the polar plot of 1 0 at origin? This is the polar plot of 1 0 at origin. Now 1 0 at origin, the polar plot is this. Yes. Now we add one more 0 at origin. This is the polar plot, s square. This is one more 0 at origin, polar plot s cube. This is one more 0 at origin, polar plot is s power 4, and so on. What is the meaning of that? The addition of each 0 at origin, see the difference previously and here. The addition of each 0 at origin shift the total polar plot by which direction? Anti-clockwise direction. By how much? Plus 90 degrees. Plus 90 degrees itself. Plus means anti-clockwise, minus means clockwise direction. So the addition of each 0 at origin shift the total polar plot by plus 90 degrees in the anti-clockwise direction, and the polar plot is a straight line only when the angles are completely independent of frequency. And the polar plot of 0 at origin is away from the origin, and the polar plot of poles at origin is towards the origin. Okay, note on this. Okay. So now you understand what happened when pole is added at origin. You understand what happened when zeros are added at origin. What happened the addition of each finite pole. What happened the addition of each finite pole. How the polar plot is changes. All these are important because in some exams he is asking like this. He is already given the polar plot and he is saying that now in the above polar plot, then by adding one pole at origin, options remains same, polar plot remains same, polar plot starting angle is shifted, polar plot ending angle is shifted, there is no change in the polar plot, like that the options are available. So such that you know what happened when zeros are added at origin, what happened when poles are added at origin. So all these changes you must be observed such that it is very easy to answer the question. Now see here. This is one assume some polar plot or path or whatever it may be, okay? This is some path or contour, part of the polar plot. So, now let us take this is some point x. Now see the point x with respect to the direction of the polar plot. This is the point x and this is the direction of the path. Where is the point? This point is right hand side or not? This is the right hand side region. This is the right hand side region and this is the left hand side region, right? This is right hand side. This is left hand side, right? So if any point is lies on right hand side of the path, then that particular point is said to be enclosed by that particular path. What is that? Now the point x is right hand side or not? Therefore, now the point x is enclosed by that path, enclosed by that path or by that contour. What is the definition? I am writing the definition. If any point is lies on right hand side of a path, then that particular point is said to be enclosed by that particular path, otherwise not enclosed. Okay. Now let us see here one more example I am writing here such that you can easily understand. Now this is the path direction, but now the point y is here. This is a path or a contour. So where is the point y now? That is, see, you see the direction and you indicate this is the direction and this is right hand side, this is left hand side. Now the point y is lies on right hand side or left hand side of the direction of the path. Now the point y is on left hand side with respect to direction. Therefore, if any point is lies on right hand side is enclosed, otherwise not enclosed. Therefore, now the point y is not enclosed by the path. Point y is not enclosed by the path. If any point is lies on right hand side of a path, then that particular point is said to be enclosed, otherwise not enclosed. Understand or not? If any point is lies on right hand side is enclosed, otherwise it is not enclosed. Okay, note on this concept of enclosed is useful here. Clear or not? If any point is lies on right hand side of a path, then that particular point is said to be enclosed, otherwise not enclosed. Now let us take for examples. This is the polar plot. For example, this is the polar plot. For example, let us take, okay, this direction is nothing but omega is changing from 0 to infinity, for example. Now see here, the plot is crossing the negative imaginary axis. Yes, this is j omega minus plus j omega plus real axis, negative real axis, positive real axis, negative real axis, positive imaginary axis, negative imaginary axis. So far, whatever the questions which we are covered is transfer function, polar plot, transfer function, polar plot, what are the changes? Okay, that we will cover. Okay, and this is the second model of the polar plot, which means that now he is asking magnitude, because polar plot is nothing but magnitude and phase angle plot. Then what he is asking is, when polar plot crosses negative imaginary axis, what is the magnitude? When polar plot crosses negative real axis, what is the magnitude? Like this. For example, now the polar plot is crossing negative imaginary axis. He is asking here, what is magnitude? Like that the question. Here the polar plot is crossing negative real axis. There, what is the magnitude? Like this the questions he is asking. Determine the magnitude of the polar plot where the polar plot crosses negative imaginary axis or negative real axis. Like that the questions he is asking. Okay. Now this is one model of the problems what generally he is asking. He is asking to find determine magnitude of the polar plot where the polar plot is crossing the negative imaginary. Let us assume this magnitude is A. We'll calculate later. Okay. Now let us assume here the magnitude is A. We'll calculate later. Like that. So what is A? A here is A is the magnitude of the polar plot where the polar plot crosses a negative imaginary axis. What is A? A here is A is the magnitude of polar plot where polar plot crosses negative imaginary axis. What is A here? A is the magnitude of the polar plot. A is the magnitude of the polar plot where polar plot crosses negative real axis. A is the magnitude of the polar plot where the polar plot crosses negative real axis. A is the magnitude of the polar plot where the polar plot crosses negative like that. He is asking wherever, whatever it may be. Okay. Now like that sometimes the questions are asking. So we will find how to find the magnitude at any particular position. Okay. Note down this. For example, this is for example I am writing. Okay. Sometimes the questions may be like this. For explanation that I am giving this.